Hi students, today I'm going to teach you how to factor difference of two squares. So to begin with, difference of two squares is the product of the sum and difference of two terms. So here is the pattern. This is a squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b. But before we can factor difference of two squares, we just need to make sure that the given binomial is a difference of two squares. So we have here the conditions for a binomial to be difference of two squares or DTS. Okay, the first one is two terms must be both perfect squares. Minus sign or minus must be the sign between the two terms, and the exponent of the variables must be even number. So what are the perfect squares? So here are the list of perfect squares. So we have 1 squared is equal to 1, 2 squares equals to 2, 2 squared is equals to 4, 3 squares is equal to 9, 4 squared equals 16, 5 squared equals 25, and so on. So when we say perfect square, this is the answer in a number when you multiply by itself. So let's have now example of difference of two squares. Okay, so write x squared minus 9 in completely factored form. So let's check first if the given is a difference of two squares. First, 9 is a perfect square. The exponent of the variable x is even number, which is 2, and the sign between the two terms is minus. So meaning we can now factor it as difference of two squares. So let's rewrite x squared minus 9 is equal to, so let's make two small parentheses. We're now going to get the square root of x squared and 9. So when we say square root, this is the one number that when you multiply it by itself, the answer is x squared and 9. So for x squared, so we're going to divide the exponent by 2. So we have x and x. And then for 9, that is 3 because 3 times 3 is 9. So we're going to write here 3 and on the other parenthesis 3. And then the sign plus and minus. So this is now the answer. Next, let's have another example. Write 16a to the 6th power minus 25b squared in completely factored form. So again, let's check first if the given is a difference of two squares. So 16 and 25 are both perfect squares. The exponent of the variables, which is 6 and 2, are both also even numbers, and the sign between the two terms is minus. So now, let's rewrite 16a to the 6th power minus 25b squared. So same with the procedure and example number 1, we're going to make two small parentheses and then get the square root of the first term and the second term. So what number when you multiply by itself is 16? So that is 4. And then we're going to divide the exponent 6 by 2. So 6 divided by 2, that is 3. So we're going to have an exponent of a cubed and another a cubed. Next is, what number when you multiply by itself is 25? Okay, that is 5. So we're going to write here 5 and another 5. And then the exponent 2, let's divide it by 2. The answer is 1. So we're going to only have 1b and 1b. And then write the sign plus, and minus. So that is the answer. Example number 3. Write a squared b to the fourth minus 81 in completely factored form. Again, check first the given if it is a difference of two squares. So, a squared b to the fourth power is a perfect square because the exponents are even numbers. 81 is a perfect square, and the sign between the two terms is minus. So, we can factor a squared b to the fourth power minus 81 using difference of two squares. So again, let's make two small parentheses. Divide the exponents by 2. So a squared will become a, b to the fourth power will become squared, b squared. Then 81, the number that when you multiply by itself and the answer is 81 is 9. Then write 9 and then the sign plus minus. So, the answer for a squared b to the fourth power minus 81 is the quantity of ab squared plus 9 times the quantity of ab squared minus 9. Next, the steps in factoring difference of two squares are: step 1, express the first and the second terms in exponential form with the power of 2. Or you can simply get the square root of the first and the second terms. Then subtract the two terms in exponential form following the pattern a squared minus b squared. And then factor completely following the pattern a squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b. Let's have another example. Example number 4. Write x to the fourth power minus 81 in completely factored form. Okay, so obviously this is a difference of two squares because 81 is a perfect square. The exponent of x, which is 4, is even number, and the sign between the two terms is minus. So let's rewrite x to the fourth minus 81. So let's make two parentheses again. So divide the fourth power by 2, so that will become x squared. And the square root of 81, or the number but that when you multiply by itself, the answer is 81 is 9. So we're going to write here 9 plus and then minus. If you take a look at the answer, the quantity of x squared plus 9 times the quantity of x squared minus 9, we can still factor x squared minus 9. This is still a difference of two squares. So 9 is still a perfect square and the exponent 2 is even number. So let's just copy x squared plus 9. And then let's make another two small parentheses for the factors of x squared minus 9. So let's divide the exponent 2 of x. So the answer will be x. So let's write x and x. And then the square root of 9, or the number that when you multiply by itself, the answer is 9, is 3. So let's write 3, and then the plus and minus sign. So there you go. This is now the final answer. So the factors of x to the fourth power minus 81 is the quantity of x squared plus 9 times the quantity of x plus 3 times the quantity of x minus 3. So take note that if the answer is still can be factorable, you should factor it. Next, for example number 5, write 3w squared minus 48 in completely factored form. As we look at the given, so 3 and 48 are not perfect squares. The square root exponent 2 of w is an even number, and the sign is minus. If we're going to take a look at 3 and 48, they have common factor. So let's get first their common factor and check if the factors have difference of two squares. So let's write 3w squared minus 48. The common factor of 3 and 48 is 3. So let's write 3, and then let's make another parenthesis for the other factor. So let's divide 3w squared by 3. The answer is w squared. Then minus 48 divided by 3 is 16. So if we're going now to look at the other factor, which is w squared minus 16, it is now a difference of two squares. So 16 is a perfect square. The exponent of w, which is 2, is even number. And the sign between the two terms is minus. So we can still factor this. So let's bring down 3. And then let's make another 2 small parentheses for the factors of w squared minus 16. So divide the exponent 2 by 2. So we have w and w. And then the square root of 16, or the number that when you multiply by itself is 16. The answer is 4. So let's write 4 and then 4. And then the plus and minus sign. So that's it. The answer for 3w squared minus 48 is 3 times the quantity of w plus 4 times the quantity of w minus 4. So that's how you factored a difference of two squares. And thank you for watching.